So while I work on some really philosophical, sciencey, interesting long-form videos, I have a couple of those I'm currently working on, I want to make some filler content that's still fun, still mathy, still STEMmy, but it's going to be mainly math, and I'm calling it the ADDvent Day 1. So it's an Advent calendar, but like math. And I don't know, I guess the problems like might get harder each time, but this is probably already like more like, if this is the difficulty spectrum, this is probably, just because I don't want to do anything like extremely complicated, this is probably like right here, where like this is like the middle or something. Something along those lines. Now, you might be asking, dude, you're Jewish, why are you doing an Advent calendar? And you're probably not asking that, because you probably didn't even know that about me. But like, it's not like there's a Jewish version, like a multiplication vent, calendar, like, I can't just change the operator there and call it a Jewish version. You know, actually, because add symbol kind of looks like a cross. So then the multiplication symbol, which we can make like, you know, that little asterisk one. Like, it's an asterisk, right? But it's technically a star. So, I mean, you could argue that. You could argue that would actually work. Not entirely funny, but I guess at least makes sense if you really think about it. I don't know. Anyway, this is our problem that we're doing today. This is day 1. And what you'll immediately notice is that this is a little bit weird, because we're going to have 2 x terms, and it's also a cubic without a squared term. It's a little bit unusual, but what we can do is we can expand this, so we get minus 5 times x, and then minus x times the square root of 5. And then we'll go ahead and add 5 to both sides. And what we'll notice here is that there's a lot of 5s, except one of them is in a square root. So we can do something with that. There's factoring potential there, but for the sake of visualizing what should happen next and keeping things neat, we're going to go ahead and make a substitution, and we're going to let the square root of 5 be equal to a, or in other words, I don't know what the symbol for that would be, but a squared is equal to 5. Right? So now we kind of see 2 naturally factorable terms. So we'll go ahead and take an x, and we'll go ahead and x squared, right? Times that, and then also minus a squared, because you see now we have our difference of squares here, and then here we can easily factor out an a, minus a, and then minus a times x, and then we'll go ahead and subtract another a. Alright, so now we can actually factor this very easily into a difference of squares. We can factor out an x minus a, and we get x minus a times, make the parentheses a little bigger, times x plus a, and then minus a. That's going to equal 0. Now, we can go ahead and split this into 2 separate cases, because we can use the zero product property, and we get that x minus a, which, keep in mind, that is just square root of 5, equals 0, or x times x plus a, which is the square root of 5, minus the square root of 5, equals 0. Here we get one solution pretty immediately. X is equal to the square root of 5. This is quadratic. We can go ahead and use the quadratic formula, which says this is sufficient for our purposes here, because we're just having fun. And x3 is going to be the square root of 5, and this is our solution set. No, why? Yeah, very fast.